Hi, I'm Tom and I talk about code. Welcome to another Rust compiler live stream. We're on a side quest still. It's last time we started working on binary formats because managing just blobs of data was a little bit too much. So we're going further down this path. Last stream we pretty much got the loader done. We can now load just generic binaries of some format. But we haven't actually tested it because nothing's outputting it yet, so I'm not going to check this off yet. But this gets like a phantom tick. It gets like a dotted tick that we're hopefully going to tick all the way later. We're going to modify our assembler to output these binaries, then we're going to see if the loader actually understands them, and that'll be a really great place to start. So let me jump across. I have no idea what I've actually got. Okay, good. I don't have anything suspicious open. That's good. I can change scene. It's always worth checking that, right? It's always worth checking. Also, I'm going to roll my sleeves up because this is going to be some serious work. We're going to jump across to our workspace, Rust, simple VM. We're going to start a recording. Awesome. So, bin fmt mod, we defined all these structs. We can load arbitrary binary data, which is cool. We can also serialize, which is also very important. Hopefully that's going to make working with the assembler extremely simple. Extremely simple. Because if we think about what these are, right, we have a header and we have some sections. Well, with the assembler, all we're going to do is compile everything into one section. Like, this is all we need right now. Put everything in one section. We're not doing static data. Our assembly doesn't even support that yet. So one section of size, length of program, mode 0, address 0, and file offset, whatever the offset of these headers is. Okay? Cool. Perfect. Now we might need a utility for working out the size of this whole thing, right? We might need, because the only thing is, yeah, we have to know how big these headers are, how big this whole header section and the section header table is, before we actually work out what goes in here. That's, you know what, honestly, that's fine. That's fine. We can do this by reference. This will make sense in a moment. So, sections, yeah. This is fine. So let's go into our assembler. Let's go into ASM 0. This is our first level assembler, our most basic assembler. We have a more involved assembler. Actually, no, let's put it in the more involved assembler. Let's leave ASM 0 as the thing that takes code and dumps out a binary blob. I think that's a safer place to leave it. So we open a thing, we dump it into memory, we do some stuff, we skip comments, and then we compile. And at the end of compiling, we have output. Output is just a big dumb output. Output is, if we're in this format. Preprocess only, yeah. So if we're in this format. So again, if we're just dumping out the instructions in human readable form, we don't care about this. But if where is output? Output's a big dumb vec8. So here, instead of just putting these straight into output, actually maybe we do put these straight into output. Nah, let's make something else. So this is not preprocessor only mode. This is actual binary mode. Let's go with this. Let's make oh, hi Bobbius, by the way. I can't remember if I said it. I did see you say hello. I just got caught up in the whirlwind, the fun whirlwind of all this compiler work. So let's say program. We'll make a new vector for this, and instead of putting it into output, we'll put it into program bytes. And actually, last stream we learnt about a new function, right? We learnt about a new function called 2bytes LE, I think, for U16. So that would let us do this without having to do this masking. So maybe we can say program bytes extend from slice. Can we say raw instruction? What is it? .2 LE bytes. Let's try this. I think there was something else I had to do, but this is better than doing that masking and stuff as off. That's way better. Cool. So now we have a vec. This has to be mutable as well, by the way. And also let's be explicit that it's a vec of U8. That's also probably kind of important. So we have a vec of U8s. That's all the bytes in our program. Now we need to make a binary file. So we'll say let bin equal, this needs to be mutable as well. because yeah, okay, so we just smash stuff into it directly. So we just make a new binary file, and I think new is okay. I guess I could also derive, and this is probably better in general, debug default, right? The default binary file is something that just has no fields, no data in it. Default with a T. Bin.entry point is going to be 0. This is in the default, but we want to be explicit where possible. Bin.version is going to be equal to, let's say version 0. Let's say version 1. Let's say version 1. We maybe should also define like latest version or something, or current version, or just like a default that things should use. And then any tools that don't work with the latest version have to have special cases. Maybe, I don't know. Maybe that's wrong. We should probably define version somewhere in this mod though. It's just so we have like a list of well-known ones. Just so we have a list. Okay. Entry point version. Then we need to add a section as well. So bin.sections push. We're going to push a new section, and this is going to be a section that. So we can say section size. It's going to be the program bytes length. The mode is going to be 0. This should probably go on new lines. It's going to look cleaner. The mode is going to be 0 because it's read write. I mean, actually, we could map this as read only. So we now have a tool to say read only or read write. Oh, okay. I'll think about that for a second. It's going to get mapped into address 0. And the file offset, we're just going to say it's like 1 for now, which is a placeholder. We have to update this later, okay? We have to update this actually right now. Now we can work out where in the binary, how big the header is. So maybe we can ask this file, we'll say, this type rather, we'll say get header size, right? How many bytes is this header as it stands right now? So this is going to be header byte size plus, it's just the size of the header in bytes plus self.sections len times section byte size. Right? How big is this header? How big is the header part of this versus plus how big are the sections times how many section headers times how many section headers do we have? That makes sense. Maybe we should give these names as well, right? That's actually a really useful thing, having a string tab, knowing that sections have names. Really useful for debugging. I don't know, it feels like overhead. String tabs, they're just a bit clunky. So now that we've pushed a section, if we try and work this out before, we don't know, but now that we've pushed a section, we can say bin sections get. Do we have to say get mut? Can I just say get? Let's say get mut 0 unwrap, because we just put something in here so we know it's there. Dot file offset equals, and it's gonna start at the size of the header, right? So the header's gonna be there, and then we're gonna have all our data afterwards, and that's all we load in. So the file offset equals bin dot header size dot get header size. Apparently, the word get's okay there. I think I'm usually hot and cold on the word get, but I think there it's okay. So I think this is good. I think this is fine. And then we also need to say bin data, and this is just a vec of U8. So bin data equals. I don't know if we can do this. I think this move should be okay. That sounds fine to me. It doesn't raise any red flags. Cool. So that all looks cool. And then we say bin.write to output. And we have to mutably borrow it. So what happens if I build this? It's going to yell at me, of course. I didn't do my chained semicolons correctly, of course. Bobbius, you posted something in my Discord, right? Oh, the Odin stuff. Did you read my response to your Odin stuff? Does that make any sense? Bobbius, he's our resident Odin expert. I want bin fmt binary file. I need to import this bad boy. Section. Oh yeah, I need to import everything from here. Actually, I need binary file. Actually, no. I just need binary file and section. Nice. Okay, so raw instructions, expected slice found this, but we just borrow it. When we borrow an array, we can turn it into a slice. Yeah. Yeah, I should do an Odin stream. Maybe I should do an Odin stream and try and write a parser combinator in Odin. Len as U16. We only... I need to think about the failure conditions for all these reckless casts at some point. Not sure how powerful Odin generics actually are. It's hard, right? You need this ability to compose generic functions, which not every language can do. And that's why the C version of parser combinators has so many void pointers, because it just uses C's lax casting to gloss over it. This is the same problem. This is the same problem. So this as U32? Yeah, that makes sense. Write 2. Okay, so what did I call this? 2 bytes? 2 bytes, not write 2. I wonder if there's a standard Rust interface I should be... a standard Rust trait that I should be implementing here. Okay, well, let's see what happens when I run this. We'll run bin... what are our binaries? ASM. We'll run it on... This is a great question. Do I have a program that I can test? This is code. What? Screentest.asm. Okay, here's an assembly program. It's going to be wrong. It's going to be wrong code, but I can compile it anyway. It's going to be wrong code because I changed the order of like add. This is saying, what's this saying? Add, store the result in BP? No. I don't know. Anyway, I changed the order of some of my instructions. Maybe that one's fine. But let's try and compile it anyway. So progs screentest.asm. Unop store. Yeah, so okay. Other things have broken. Progs screentest.asm store byte, I guess. Cool. And here's our program. This looks like something. There's a lot of zeros, but that's okay because actually no, that's too many zeros. That's too many zeros. It's too many bytes and it's too many zeros. Where clauses don't restrict types in the way they do in Rust, the intrinsic functions for checking types expect concrete types. Yeah, that's a problem. That's a problem. They have RTT. So yeah, you can do it at runtime, but I don't know. That feels gross. That feels kind of gross. Okay, so let me dump this out. Let me dump the output into, let's just call it T, because I wrote a binary last time as well called bin dump. Yeah, so we can run this here. And it looks like we actually calculate this correctly, which is cool. I don't know why this offset is 10,000. There aren't 10,000 bytes in this file. This header isn't 10,000 bytes in size. However, what is hex 2CO? 704. Nowhere near. Why is this a link? Get out of here. Taking a dump. Exactly. Thank you. High quality comment. So that's weird. This is good, right? This is why we do this. This is why we test before we say things are done. So we work out the start of the header looks good. Let's write something more outrageous in here. Let's write like 99. And I should actually write a test in a test file that does like a round trip. That's actually a pretty safe way, I think, to start to visualize this. 99. I think this is hex 99. That looks about right. Right? 6 hex. I can conceivably believe that this is hex 99. So why is everything padded out to like a word, right? That's what this is. Everything's a word. Maybe not. It just feels like one or two out of every four For what? Hold on. Yeah, no, sorry. So this is this whole thing. So this is a 32-bit word. This is a 64-bit word. So it feels like 4 out of 8 or less of our bytes are non-zero, which is not correct. Also, this offset is ridiculous. Like, why is the offset 65,000? So, what could be going wrong here? Well, get header size. How are we working out the header size? Get header size. Byte size plus the length, the number of sections, right, which should be right, multiplied by the size of, and I did BODMAS. I did BODMAS. So another fun thing is I can actually, hopefully, pipe this directly into bin dump. Yeah, nice. That's really good. It's like a snake eating its tail. You just pipe one command into the next. So, okay. I've got a radical idea for how I can hone in on what's gone wrong. And that is to say, just println it. We're just gonna println it. Header size equals header size. And it could be the cast to U32 that's causing a problem. It could be. Header size equals 38. Why does this happen so many times? Am I doing this for each? Oh, for line. Hold on, I'm doing this for each line. Whoa. Why did I do this? Why did I do this? Wow. So inside my loop, I'm deciding, okay, this is garbage. This is garbage. I've got to duplicate this loop. So if args.preprocessor only, then we'll say this, then for each line, we do this. Yeah, cool. For line in process, yes. Okay, so we do that. And then our else moves down a level. We resolve again. We just copy and paste this. This bit has to get copied and pasted. That was really bad code. Oh, and we also have to put the for loop in. For line in processed. Cool. And these brackets should actually have just leveled out. Yeah, cool. Okay, that's way better. That's way better. No wonder that felt disgusting. So this has to come down here. This goes outside the loop. No wonder that was such a big number. Because, well, I don't know, it's weird. It's weird. There's definitely something weird going on there. But the program bytes have to go outside here. Okay, nice. Args preprocessor only. Preprocess only, no or. What's the suffix called where it goes from a or to a, what's that called? It's got a name, right? Okay, nice. Let's get rid of the println that's gonna break everything, and then try chaining these again. Okay, that offset's still a bit wrong. That offset's still just a little bit wrong. Just a tiny little bit. The good news is we're no longer going to be writing an entire binary for each instruction, so we should be able to inspect this manually much easier, right? Because before, because we were doing it for each instruction, right? That's why we saw this printout. So we were writing this many binaries, which isn't good. You don't want that many binaries. Nice, this looks much more sensible. So we have version 99, we have offset, blah, 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 other stuff, and then you can very clearly see where the program starts. That's good. That's really good news. Where's this mysterious number? 2703, blah, blah, blah. So it looks like this might actually be a deserialization issue, because if I look at this, like, again, let's open up Python and let's look at the hex representation of, look at the hex representation of this number, hex of this. Like, this doesn't even fit, right? 1, 2, 3, 4, 5, 6, 7, 8. Oh no, that's like one of the biggest 32-bit numbers that we could have. So one A1239190, A1231910, oops, A1231910, A123199190, A1239190. Okay, this is Bobius was complaining about this yesterday, byte order, but this is actually what gets written. And there's no way to cut this. This isn't just interpreting bytes in the wrong order. This isn't just like little endian versus big endian. This is fundamentally doing some real garbage. Something really, really strange and jank. Oh gosh. Oh, Augusto, sorry, I missed your follow. I had some garbage Twitch notifications blocking my view of that part of the screen, but thank you very much for following. Thank you. I keep thinking I should have something like at the bottom, like underneath my window here, where the illegal zone where my mouse cursor can't go. I should have some kind of scroll down there. I don't like full screen follow notifications and stuff, things that necessarily take away from the actual content, but I think I definitely have some spare real estate in this setup where I could do that. And I think that would be really good, and that would help me see it as well. Because I have a stream preview where I can see it now, because if I don't, Are we reading instructions as though they're part of the header data? No, we shouldn't be. We shouldn't be. Because the header doesn't exist at runtime, right? The header, instructions as though they're part of the header data. It shouldn't, right? I mean, for one, oh, hold on. I think I see what you're saying now. That might make sense, yeah. But why would... Okay, what I need to actually do, right, is count these bytes. So you're saying this is actually the start of the program, and that does actually make sense. That actually makes a lot of sense, right? That this this looks like where we... Because... Oh, hold on. You're spot on. Sorry, they took me a second to work out what you were saying. You're spot on, because look at this offset, right? So this is 202122, okay? So hex 22, and it looks like we're probably saying the offset, the start of this data is at 28 or 26, so we're off by a little bit. But we're probably writing this data too soon. We're probably writing the data too soon. Ah, that's interesting. That's very interesting. So the problem, it's probably header 2 bytes for each section. So we're pushing to a vec. So this really can't be wrong with the offsets, right? It can't really be wrong. So when we convert a section to... Is this number wrong, basically? Have I calculated this incorrectly? We write size, which is 2, 4, 8, 12. No, so there's no way. There's no way. We're pushing... Ah, hold on. No, that's fine. That's fine. Yep. That's the offset. It's the offset. From bytes, 2 bytes. Size, mode. Yeah. So it's really, really straightforward. There isn't a lot we could be doing wrong here. So, let's maybe dump this to a file, just so I can go back and forward, all right, and work out what's going on. Actually, here's what I'm gonna do. This is gonna be even better. Okay, this is revolutionary. No one has ever done this on my stream before. We're gonna work this out by hand. Actually, even better, let's get the column offsets as well. Let's get the like offset column as well, I should say. Okay, so let's jump in and work this out. But yeah, Bobius, I think you're actually absolutely spot on. Oh, this is good. This is really good. Open as layer. You can't see the window that popped up. You can't see my home directory while I'm finding this, because my screenshots will go into my home directory. Okay, here we go. Let's annotate this this image. Let's work out what's going on. So we'll merge it down, I guess. Now it's part of here. Okay, so this is the version. We know this is the version. Let's get a smaller pen, because this is actually, let's scale it up. Let's make it bigger, just so I can draw on it more. That's maybe too big. No, that's good. That's good. Okay. Now we're gonna merge it down, and now we're fine. Now we can draw. So Should I make my pen bigger, my pen smaller, or the thing bigger? There's only one answer to that. This is the version. Man, this brings me back to PS2 streams, just like drawing on buffers, on actual byte buffers. So, version, entry point. We'll just call it E. And then we have 4 U8s for hardware conf. We'll call this HW. We'll call this HW, where you can actually see the H and the W are separate. We have a section count, which is here. We'll call it number of sections. And then we have 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the end of the header. This is our res. Awesome. So now we have a section. Now this is our first section. Okay, and a section is a size, which is here, a mode, which is here, which we expect to be 0, an address, which is going to be here, which again we expect to be 0, and then an offset, which is here. So that all looks good, and then the program starts. So yeah, Bobius is right. This is the start of the program, but we're trying to interpret this as a offset for some reason. So we're off by 4 bytes, basically. We want to be looking here, and instead we're looking here. Cool. Okay, that's solvable. That's fixable. That's fixable. So, vec from bytes. Vec from bytes looks like a good candidate for what could be going wrong here. This could be our problem. This could be our problem. So when we go from bytes, what happens? We get the size, we get the mode, we get the address, we get the file offset. Perfect. When we go 2 bytes, what do we do? Size, mode, address, file offset. Also perfect. Also perfect. Also good. So when we do a vec from bytes, is it possible we start off? I don't think it is. I don't think it is because the rest of the data looks okay if I go back to this. Mode, address 30. Okay, no, hold on. This is it. This is it. This is literally exactly it. So why is the address 38? The address should be 0. Well, what's this? 26? Hex 26? Can anyone do the math for me? That's 38, right? That's 32 plus 6. That's 38. So we're reading both of these fields off by 4. What's your bet that we're reading these off by 4 as well? The problem is, and actually, yeah, the size as well. So we're almost certainly starting here, right? As opposed to starting over here. Okay, that's easy. That's easy. We can fix this. We can fix this. We can fix it. Why? Why are we doing it? What's happening? I times the size in bytes. I should be 0. I should be 0. Section data, section end. From bytes. Sub data. And we get the subsection. So this should be okay. This should be okay. From bytes. So is it possible that when we call vec from bytes that we're not giving it the correct offset? Sections offset is the size of the header. I think I've misused this. Because oh no, this is the data offset. Hold on. Sections offset. Sections offset is the size of the header. No, that is correct. That is correct. Have I miscalculated the size of the header? That would actually do it as well. That would do it as well because 26. So we actually think that the program starts at 0, 1, 2, 3, 4, 5. We think the program starts here. So it's not just this. So what I suspect is I've made a mistake and the decoder thinks that the header takes up this much extra room. That seems like a plausible problem. So, vec from byte. Actually, no, the easiest thing is, how big do I say a header is? Byte size 26. Okay, so 12 plus 4 is 18. Is 16, sorry. Maths is hard. 18, 20, 22. Wait, is that right? 2, 4, 6, 10, 22. What did I say? 26. That would do it. I forgot to show it, but it's not that important. Because, yeah, it's just easy. So maybe I should be using Rust to work out the size of this thing. Maybe that does make more sense. I'm scared of alignment, right? I'm scared of alignment. Because the size of this thing, in the way Rust lays it out, may not actually be the number of bytes of the fields, like the sum of the number of bytes of the fields. So I'm scared of doing it. I'm terrified. Let's see what this says now. Size 40, offset 34, address 0. Does this look right? Size offset 34, 1, 2. I still don't know. I could tell it to lay it out as a C struct. Even C structs are not necessarily densely packed, right? Tensor Theru, thank you very much for following. Welcome. Hope you're as excited about binary formats as I am, because oh boy, this is a journey. This is a journey. I am also going to have to leave in about 20 minutes, sadly. I'm going to play Irish music. I wasn't sure if I should have streamed now or later. I might come back later if I've got more time, but I've got a fun. I've got a date with a flute. That sounds horrible. Okay, don't quote me on that. Don't clip that. Okay, so something still isn't right here. Something still isn't right here because maybe it would be fun in bin format. I don't know if I finished my train of thought before. Sorry, but yeah, C structs are not necessarily tightly packed, right? If you have a field that is a car and then a field that is an int, or like a uint64, say, right? How do they get laid out? What's the size of that? Does that depend on your platform? Does that depend on, like, how do you have to pad that? I don't know if there's one universal answer. C structs with a packed pragma are consistent, I believe, between hardware. I'm still not entirely sure that that's true. As long as you order the fields biggest to smallest, I think they probably are. But that's scary, right? Memory layouts are scary. And yeah, I just don't understand how Rust does it. So anyway, bit of a sidetrack. This whole thing is a really big side quest for supporting strings. Is this offset correct? Probably. Oh no, 32. 32. Hold on. It is correct. It is correct because this is 32 and this is 32 plus 2. So it is correct. Okay. So can we make the virtual machine load this binary? Can we do it? Probably. We have load to, we wrote this function. So let's try it. Let's try it. When we load our binary, instead of just, bin VM, sorry, instead of it just coming in somewhere, we map in, and this was kind of cool, right? Like we have a memory map buffer, we put the program in memory at address 0. That's great. But instead of this, let's say VM, let's say let bin equal binary file from bytes. And I think I need to unwrap this because it's errory. It tastes like an error. It tastes like failure. From bytes. Beautiful. And this needs to be a ref. Here we go. Repr packed x. Okay. That would be good, actually. That is exactly what I want. So I could have a play with that. I could have a play with that. Awesome. Welcome everyone coming in. Welcome everyone coming in. We are building. We are building. So we've got a binary. Now instead of mapping this manually, we just say, what's this function called? Load to VM. Load to VM. We take a mutable ref to our VM, and that's that. That's all we need. And it's a result, so we have to unwrap it. Now we don't do this map manually anymore. And we also want to manually set the program counter to the bin entry point, right? We want to manually set this up. The entry point's 0 right now, but it might not always be. It might not always be. Cool, so refc align x, I want to prevent fields from being moved. I actually don't care about fields being moved because I am manually serializing and deserializing them. So Rust can actually reorder those fields in memory, and that would be fine. But that would be good. It would be really nice. Well, but again, does reordering change the size? I've got to read, and I'll do it off camera, but I've got to go and read about how repapact and repac align work, because it's just scary. It just really scares me. Okay, so if I build, what happens? Binary file is not imported. Also, memory map buffer. I like it when I can remove an include. That's nice. So we want bin fmt binary file. Awesome. So let's try. This is the moment of truth, and it'll probably blow up for a whole host of interesting reasons. But let's pipe this into cargo r bin vm file read out of bounds. Excellent. Excellent. Section 0 file read out of bounds. So it's trying to copy a file, copy data from a binary into the file, and it's telling me that, hey, there's not enough data here. The only data layout guarantees made by this representation are those required for soundness. The fields are properly aligned, the fields do not overlap. The alignment of the type is at least the maximum alignment of its fields. Yeah, so this still doesn't guarantee that the number of bytes is what... this still doesn't guarantee that if I ask Rust for the number of bytes that it will be what I need it to be. That basically, I think I would need to write my own proc macros to... Well, I'm sure someone else has done it, but it feels like something that needs a special proc macro for, potentially, because it's my own format, right? Or like hooking it into serde directly. Is it serd or serde? I never know. But yeah, this still doesn't quite solve my problem. My problem isn't representation in memory. My problem is Rust, not trusting Rust to have the exact number of bytes of the struct equal to the sum of the size of the fields of the struct. I don't know exactly what directive to use to tell me that. Okay, so when I'm trying to load this, something has blown up. Something's blown up. Now, file read out of bounds. The word file here is a little bit problematic, but we're going to gloss over that. The file offset plus the section size. So it's saying we're reading from here to here. Now, is it possible that this is an off by 1 problem? Can I just subtract 1 here? How does that go? No. Okay. That's interesting. Let's also print out the length of the data. So let's say self.data.len, because this is the thing we're slicing, right? Unexpected token, because I need a comma. 40. So this has a length of 40, 30, 40. So why doesn't this... Oh, yes. Very good. The start, these are offset by the size of the header, right? These are offset by the size of the header. So I need to subtract the actual header size from this. Thankfully, I have a method for this, right? I have a method called getHeaderSize. So let's say let header size equals self.getHeaderSize, and then we subtract this off. We say header size, we subtract it off after, minus header size. Minus header. Wait, we've already subtracted that here from the start, and that doesn't... Okay, so we do this. Nice. Now this is fine. This is fine because we've changed the order of these things around. This is not an unreasonable error to see. We've changed how some of these instructions work. This loads and runs correctly. The first instruction, im_a400, im_b. If I look at im_a, im_b, shift left, add a, im_b, shift left, add. So this loads and runs correctly. So we have a binary format. We've done it. Let's add this up. VM source. Use binary format in ASM and bin VM. But ASM 0, we're still gonna have a binary that just takes instructions and spits out raw binary blob, like no binary format. The next, okay, so hold on. We have a really important thing we have to do here. Okay, we've got a really important thing to do here. This is no longer a phantom check. This is now a real check. We now run it we now output this from the assembler. So we can load our binary format, we can assemble to our binary format. Can we make the compiler output it? This is, oh boy, this is the big one. This is the big one. Oh, hold on. I didn't actually commit last time. I keep forgetting to run cargo format. I keep forgetting that that makes me do that. Also, it's probably worth just doing a quick, what does Clippy say? Clippy has a few things to say. Okay, we won't, maybe I'll do that. No, I won't do that right now. Let's go into code gen, compile top level, the place where we do, actually no, it's in context, isn't it? Get instructions, right? We get a vec of instructions. Okay, so one of the interesting things about my current APIs for the compiler is I have to give things back in a very flexible way because you might want to do different things with it. Once I'm outputting a binary blob, it's a lot less important to be flexible in the format I give things out because you'll be able to do things like get debug symbols from the binary, right? So that's going to help a lot. That's going to help a lot. Oh, I'm going to have to do string tabs, aren't I? I'm going to have to do some kind of string table because I want to have symbol names. Oh, I was hoping to avoid that, but well, this is the world we live in. What a catastrophe. What a shame. Okay, so. String tabs aren't too scary. You just dump a bunch of data in there and it's fine. It's fine. You just point us into a big dumb list, but I don't know, it's just annoying. It's just annoying. Okay, so lang bin. So this, right? This thing that prints everything out. Run parser. We get a program. Yeah, so this is the format, right? So if we're just outputting assembly, let's just continue doing what we're doing, but this is where we want to change, right? This format's still kind of useful sometimes, I guess, but this is going to be the good stuff. So get static data. Get static data. Get the offset of the statics. I don't know if we care about the offset of the statics, right? We still have the same problem here, basically, which is that we need to work out where we put these. If we put them before the code, then all of our code has to know what offset it's at when we allocate, like what is the address of a function. If we put it after the code, we have the problem that the code needs to know where those symbols live. Like what, how do we reference them? What address do we use? And I wrote a checklist for this, actually. I think this was on this document somewhere. Yeah, it's here, right? Where I said we would do this in a couple of passes. Okay, I said we would compile all functions, and then we would, all function calls use deferred labels. There's no relative jumps that depend on the address of a function, right? Within a function there are only relative jumps. The only absolute jumps depend on symbols that get resolved at the last stage of compiling. So that's okay. So functions don't actually need to know where they live, where they're placed, until after we've compiled all of our code and worked out how many strings or statics we have to define. So we can do this, right? It's a bigger change, but we can do this. And this is good too. This is what I thought I was working with before, where the loop over instructions happens inside here, right? Happens inside here. We can make this change as well, which is good. We can not do this. We fix this in the other binary. Okay. I'm stalling a little while I get this into gear in my brain. I also have to leave in about 10 minutes. So is there something smaller I can bite off? No, I think I just have to start biting it off right now. Okay, I'm gonna start. I'm gonna make some step towards this. The biggest step is gonna be to come into the compiler, the top level function, okay? And where we place functions, copy this function to depths, define arg. Yeah, so where we do this, right? Where we actually define where a function lives, we need to defer this. Now this is actually inline assembly. So we'll do it for the function first. We'll do it for the function first. So we have a path where we handle all globals, right? we've handled all globals. That happens up here. This comment is probably a little bit misplaced, but we've handled all our global definitions. We have a second pass where we generate all of the code for all of the functions. Functions push block. Now, local offset. Block local offset. Block register labels. Program offset. Okay. See, I don't think we need to do this yet. Block register labels. Yeah, this should be the very last thing we do. But the block local offset. Local offset's fine. Local offset's fine. This needs to happen at a later point. Block program offset. Okay. This needs to happen at a later point. Up here somewhere, right? We have a pass where if we have a function definition, we forward define it. That's fine. That's all good. But we can't actually do this. So we need a last pass. Function, we'll call it a function allocation pass. Right, so if we have a function definition, we have to actually decide where to put it, right? So decide on program offset. We have to get block associated with function. This is fine. We can actually do this. We can actually do this. So it's all this stuff up here, right? Block size. So anything that touches program offset does not belong here. Program offset, program offset. And actually, we don't even need to go over this. We just need to loop over all of the functions in the context. So this isn't even quite right. We just need to say for f in context.functions, right? Yeah, that's fine. Function offset resolution pass. That also is good. It's not even resolution though, right? The offset resolution is the next step. This is actually where we decide the address within the code that the function lives at. Now, we still have this problem where, well, we don't have this problem actually, because we're going to use this same deferred resolution system for, placing our strings. I think that's good. Function offset. I'm still going to call it allocation. Because yeah, resolution is it's not quite the right thing yet. It's not quite time to resolve yet. So we want to say context define. We want to define a symbol. So the block, what is functions? It's a vec of blocks. Perfect. So block.offset. Block.offset. What's block.offset? Hold on. Block.offset. Does the block try and know where it is? What is offset? Register label. That's okay. Function offset plus offset. Why do we add offset? Oh yeah. Offset within the thing. Yeah, that's fine. That's fine. So what's block.offset? What's self.offset here? Is this used? Why do we have this? What's going on? What is block.offset used for? this is kind of weird. Block offset equals okay, so we just want to do this. Do we say itamut or something? Do we have to do it mutably? Let's get rid of this. This is fine. Let's say, let's do this. We'll work out, we've got to work out the block size as well. So we tell it the offset, and we're gonna grab it as a block. We'll call it block, that's good. I don't know if that works. I think I need to tell it we're iterating mutably. So we calculate the size of the block, that's good. We put block. Now, do we know the name of the function? No. This is a problem. This is the biggest problem. We don't actually know the name of the function. So let's say to do get name of function somehow. And I might do that off camera. I don't think that's going to be particularly interesting rewiring, but this now means that our functions are in, and we can literally just delete some stuff here, right? We delete this, we delete this, we delete this, and we delete this. Beautiful, beautiful. Function definitions, we don't define this here. We don't need to work out the block size either. Wait, local count we do need to know. Local count we do need to work out. Okay, cool, that's it. So we've just simplified our code gen, which is good. This needs a cleanup. This shouldn't be so much code here, but that's okay. And then we just go through at the end and we in place our functions. This is good, this is good. And now it actually doesn't matter if we try and put our static data before or after, we'll just be able to refer to it. We'll be able to refer to it by a symbol that gets resolved at the last point in compilation. All right, that was fun. That wasn't as much as I hoped I'd get done, but I do have to run off now because I'm going to be playing Flute for the next couple of hours. I might come back online later because I'm having fun and I've got a couple of viewers. So let's quickly find someone we can raid. If anyone has any raid suggestions, I always love to hear them. We will do it kind of speedy because I've got to get my shoes on and get cracking. I've got a tram to catch. What is good? Oh, someone's making a qubit clone. We're gonna raid the person making a qubit clone. I think they're New Zealand too. So let's do that. Let's do that. Thank you everyone for tuning in. Bobby has played flute in high school. That's amazing. That's amazing. I do really want to make my my stream a little bit nicer, or a bit more professional, a bit more polished, and I've got a couple of things in the works. I might build some of them on stream at some point, actually. That could be fun. But let's go check out what's happening in this land of KiwiBird. All right, I'm Tom. Have a good one. I'll see you very soon.